Hi everyone, my name is Victoria, and for this project I used population demographics and air quality data for US counties to build several models to predict the air quality in a US location based on its demographics. So I was originally working with a different data set, but after bringing it into R and seeing how much important data was missing from it, especially in the features that I really wanted to include in my model, I decided to change my data set and my project to this one. So the air quality and population data sets were really interesting to me because I'm interested in environmental discrimination, like environmental racism, and I wanted to see if that was maybe prevalent within this data. Data sets I used for this project were racial breakdowns, so percent of white, Hispanic, Black, Asian, and Native American people by county, gender percentages by county, and percent of people in poverty by county. And I got all of this data from the various data tools that are housed on the US Census website. So they have, you can see here, a nice tool for getting population and race data, and I also used their tool for getting income and poverty data. And for the air quality data, the EPA actually has a lot of recorded air quality data that's available for download. Ideally, I wanted to use recent data, so data from 2016, and I wanted as much data as possible so I can make a good model. But what I was finding was there was only data by states for 2016, which is only about 51 records, which includes DC. So I looked into more data that the census had available online, and there was county data available for all of the population statistics for 2010, and there was also air quality from the EPA by county available for 2010. So I decided to use the 2010 data because that would give me a lot more records to work with, and I don't think it's old enough to be considered insignificant. So after getting all of that data, I looked at how it was formatted. If you can look at the data here in R, you see that the air quality data just had straight names for state and county, but the poverty data had numbers for states and was formatted differently for the counties. And so was the race data, and the gender data was very similar to the race data. So in order to make it all uniform, and so I can match it up later when I create a big data frame by county for all the data, I had to do a little bit of text processing. So after I did that all here, you can see that the air quality data now looks very similar to the poverty data and the race data. And the gender data also looks similar to this. Now for the air quality data, it had this column where it said how many days were actually data was recorded and how many days out of those days were good days, moderate days, unhealthy, very unhealthy, and hazardous days. So to make it more uniform, I decided to make the good, moderate, unhealthy, very unhealthy, and hazardous days as a percentage of all of the days recorded. So I did that here. And now you can see that the good days, the moderate days, and all the other columns are as percentages of all of the days that data was collected for that location. Adding all of the data, I wrote it out to separate CSVs by air quality, the poverty, gender, and race data, so I can import it later into my SQL database. So then I moved on to actually putting my data into a relational database. So my SQL database had a table for each of the features that I wanted to use in my model. So I had a table for poverty, gender, race, and air quality that had all of their attributes. So for example, for race, I had white percent, Black percent, Hispanic, Asian, and Native American percent. And they all had state and county variables as well that I can later combine them all into one data frame by state and county. And I did this so if in the future somebody else wanted to add a different feature, so for example if they wanted to measure water quality or citizenship status, they could just add another table into the SQL database. As I imported my population and air quality data into the database, I noticed that all of my records weren't being imported, and after looking and searching through the data for a long time, I saw that there were some Spanish characters that my SQL wasn't reading in. After deleting that data, all of my imports worked, and then I went back into R to pull out all the data into a data frame from my SQL with all of the data combined by county. So first I established a connection with my SQL, and then I did a really big join clause that basically just combined all of my tables by state and county onto a big data frame that you could see right here. So as you can see here, now I have all the data by state and county. After getting all of the data into a data frame from MySQL, I decided to look at the data by visualizing it through Tableau. I thought it'd be a cool, new, interesting way to look at the data in a visual way, and I just recently learned how to use Tableau. So I made a few maps of the air quality by county and the percent of white people by county and poverty by county. And then I also made an interesting visualization of poverty versus percent of white people per county. So as you can see from this graphic, the smaller circles, which represent a low percentage of white people, are mostly darker colored than the bigger circles, meaning they have a high poverty percentage. This means that areas with more white people usually have lower rates of poverty, which is not really a new statistic, but I thought it'd be nice to actually see it visually from the data. So then I actually started working on the model for the data. So I began by first identifying outliers in the data. The first model that I built was to predict the percent of good air quality days based on poverty, gender, and race percentages. I identified outliers in the good air quality days column by finding records that had air quality values with 3 or more standard deviations from the mean. So if I just run this chunk here, you could see that there were only 8 outliers that fit that description. And because I'm dealing with air quality data, I decided it would be best to leave outliers in because it represents the data more fully. And I didn't think that these outliers were due to mismeasurements or miscalculations, because from looking at the data, you could see that counties with low percentages of good days, so all of these outliers here, had high percentages for unhealthy days or very unhealthy days. And I thought this was important data to keep in. So next, I wanted to see if the distribution of good days was normal, because for my linear regression model, this is important. So I did this by making a histogram of the data that you can see here, and you could see that it's pretty right skewed. To normalize it, I tried a bunch of transforms, and the square transform really worked well to normalize the distribution, and then I applied that transform for the good days variable in my data. After this, I ran ANOVAs to see if some of the features were enough to predict good air quality by themselves. So you could see here that I ran an ANOVA for male percentage, and because the value is less than 0.05, male percentage is enough to predict air quality by itself. So I also ran ANOVAs for white percentages and poverty percentages, and for white percentages, it showed that because the p-value was less than 0.05, that white percentage alone is enough to predict the number of good air quality days. But poverty percentage did not have the same result because the p-value was greater than 0.05. So then I did some ANOVAs to see if these features would be good predictors when other features were present. So from this ANOVA that you could see here, the male percentage and the white percentage were still significant predictors, but the poverty percentage with other features still was not a significant predictor. Then I created a few scatter plots for the data and calculated Pearson moment and Spearman rank correlations for the same features with good air quality days. So you could see in this scatter plot of male percentage versus good days, there doesn't really seem to be a strong correlation between good days and percent of males, as well as in this white percentage versus good days and the male percentage versus good days. So then I went on to calculate the Pearson moment coefficients and the Spearman rank coefficients. So here for percent male and number of good air quality days, the Pearson moment was 0.28, and then the Spearman rank coefficient was 0.32. So these aren't too far apart, so you could see that the outliers aren't really having a significant effect on the data. And this was very similar in calculations for white percentages versus good air quality days and percent of poverty and number of good air quality days. So while all of these showed that outliers weren't really having a significant effect on the data, these were all really, really low and were pretty close to zero. The highest was 0.329 for percent male and number of good air quality days, but even for percent poverty, the number was very, very close to zero. And although this shows that there is some correlation, because these numbers are less than 0.8, it shows that the correlation is not really that significant. So now it was time to actually build the models. So to create my first model, I split up the data in half. You could see that I did that here with the sample function. I did it randomly, and then I created a linear regression model with all of the features using my training data set. And then I used backward fitting to take out the highest p-value above 0.05 at each step of the backward fitting until all the p-values were less than 0.05. And you can see here now that they are all less than 0.05. So then to assess the model, I calculated the prediction accuracy of the model by applying the model to my test data set. And before doing that, I unnormalized my test data set because previously I applied a square transform to it. And the prediction accuracy came out to be 38%, which means that my model is correct only about 38% of the time, which is very low. And then both the adjusted R-squared and the multiple R-squared are very low as well, and they're significantly below 0.7, meaning that the variance of good air quality days is not really significantly explained by my model. And the calculated MAD for this model is 28.66. It's also not very close to zero. That means there's a significant amount of deviation in the model. But because all the p-values are below 0.05 and the overall p-value of the model is also below 0.05, this model is statistically significant. So then I decided to create a second model to see maybe if I also look at moderate air quality days, my model will get better. So for this model, I decided to combine good air quality days and moderate air quality days to create a column called acceptable days. So then again, just like I did for the last model, I identified outliers. And again, for the same reason, I decided to leave these outliers. Then a histogram was then again made to see the distribution of the acceptable days now. And this distribution is again significantly skewed to the right, and that's because all the percentages are pretty much around 100 or 90%. So I tried a bunch of transforms on this data, but none really worked because of the very heavy right skew. So I left the data as is, so that might also have a significant effect of how the model turned out. So then again, I split up the data into test and training data sets, and again built a linear regression model from it using backward fitting. So now you could see that in this model only the race features were the ones that were significant and the poverty and male percentages were not significant. So again, I used the same methods as I did for the first model to evaluate the second model. And for this model, the prediction accuracy was actually lower than the first model. It was about 24%. Which again means that the model is really not an accurate measure of predicting now acceptable air quality days. Again, for this model, the adjusted R-squared and the multiple R-squared are very low and below 0.7, meaning that there's even less variation in the acceptable air quality days that's described by the model than the previous model. And then the calculated MAD for this model is 0.074, which is actually pretty good because it's pretty close to zero, and it's much closer to zero than the previous model, meaning that there's not really a lot of deviation in the model and that there's a lot less deviation in this model than the previous model. And that makes sense because most of the data is around 90 to 100%. This model again is also statistically significant because all of the p-values for all the features are below 0.05, and the overall p-value for the model is also below 0.05. So I also ended up calculating the AIC and BIC for both of the models. The AIC and BIC of the second model are much lower than the first model, and this means that the model is more likely to be true and is closer to the truth than the other model. So overall, I hypothesized that building a model with these demographic features would be a good predictor for air quality in the United States. However, from the two models that I built and the data that I aggregated, this does not seem to be the case. There's a few reasons why that could be. First, maybe there's not enough data. I had about 3,000 records for the demographic data, but there was much less data for the air quality, meaning that maybe the areas that didn't have their air quality recorded had the correlation that would have contributed to a more successful model. Or maybe the correlation doesn't exist at all. I don't really believe that this is the case because it's been shown that this correlation exists for water quality from the many environmental racism cases in the US. Or another reason for why this model might not be a good predictor is that the data is too old and that in 2010 air quality was really not dependent on any demographics. I don't really think that this was the case because 2010 was only 7 years ago. But thank you so much for listening. This project really allowed me to go through the steps necessary to create a full data science project, and it was a really great learning experience to go through the entire process. Thank you.